I'm Jeff Yarger. I'm a professor of chemistry, biochemistry, and physics at Arizona State University. I've created a series of lecture notes over the years of both being a student and instructor in this area that I provided online at biopchem.education in several different sets. And this video is meant to introduce set number 1, some of the content and features of it. So I've provided an introductory slide where I do give a table of content to what is existing in this first set of lecture notes. There's going to be numerous sets, probably on the order of 5 or 6 total sets that will cover most fundamental areas of thermodynamics with a specific emphasis towards biological systems. But for the first set or two, it mainly sticks to some of the core fundamental ideas in thermodynamics. While most of this information is found in numerous textbooks, one of the reasons I provide the lecture notes and what I consider useful for them for students trying to learn the subject is I've tried to, at every stage, provide every detail in any type of formulation or calculation with no assumptions or steps left undone within the lecture notes. So while I might not cover as broad of an area as many textbooks or summarize it as concisely, this is really often meant to basically add to a textbook to where you get to a concept in a textbook that maybe you don't understand the assumptions or how they get from one equation to another, or how they get to some formalism. And hopefully my notes on this area will be able to give more detail, more in-depth detail about this so that you'll be able to better understand some of the generalities in thermodynamics. So I start with defining all the terminology, vernacular, vocabulary we use in thermodynamics. And one of the other things I do pretty early on is to state what we mean by this macroscopic theory and some of the principles of it, the postulates and the laws that define it, the 3 laws of thermodynamics and 0th law, the postulates that Herbert Callan popularized, etc., in physics. But at the same time, we also, besides going through some of the formal definitions, we also sit and cover some of the basic mathematics behind it. So that you have one resource to sit and look at to really help define, because a lot of thermodynamics, the properties, when we say, for example, a quantity like the internal energy or the enthalpy or entropy is a state function, really that implication of that is all based in mathematics. It has to do with that what we're talking about are exact differentials. And so what do we mean by that? Well, that's what this series of lecture notes goes through and tries to give some very specific examples of total differentiation, different partial derivatives, what we mean by exact differentials, meaning the mixed pairs, etc. So each one of these is covered in a little vignette or 1 to 2 pages where I try to highlight what the topic is on. So I come back to math later, but I introduce what you need to know about state variables, why things are path independent from a fundamental math standpoint before moving on. We also cover what I would call just some very basic calculus things that you find in any of your introductory books. But again, for completeness, I try to show an example here of things like the chain rule, etc., that are used extensively, because really a lot of thermodynamics is an exercise in the mathematics of partial derivatives. So we cover that in some detail here. Then we talk about equilibrium, reversible versus irreversible. And again, I try to not only be very detailed in going through every single step of comparing reversible versus irreversible and talk about it, but also to state all assumptions and to provide some examples as I go through some of this. This first set of lecture note really covers the first law of thermodynamics. I introduces a lot of the vernacular we uses, covers the first law of thermodynamics and its implications about equilibrium, etc. We also introduce thermochemistry, introduce calorimeters, and some of the, again, showing exactly some of the steps that are used when using calorimetric measurements, and several examples of this. So each one of these is on the order of somewhere in the 50 to 100 page range. And again, I try to also stop and not only define what I mean by combustion reactions, but also give examples of combustion reactions as well. So the first set of lecture notes, again, basically covers the calculus needed and the first guiding principle in thermodynamics, which is the first law, conservation of energy, and the various forms of energy that you most commonly see in thermodynamics. I'll create a video on each one of the individual lecture notes to introduce them, like I have this one, and I hope you find them useful. And again, you can find them at biopchem.education. Thank you.